Romero. I'm the CTO of EUS Networks. We are Asterisk integrators headquartered out of New York. We've been working with Asterisk since 2001, and we are talking about local and remote survivability for Asterisk systems today. So just to break down the layers of survivability we're going to touch on today, we're going to talk about TDM layer, SIP trunking, termination, and transcoding. Now I'm including termination and transcoding together, obviously, because we like to transcode at the media gateway layer when we have to, rather than transcoding at the core. That's just our personal design philosophy. Then we're going to touch on core PBX signaling, proxying. Now, Klaus is going to, I assume, touch on Kamalio extensively, so I'm not going to, but everything I'm talking about today, as far as SIP signaling is concerned, and routing and policy routing is concerned, is all Kamalio based, and we are as much indebted to that project in terms of what we're able to deliver as we are to the Asterisk project. And so when I'm talking about SIP routers and SIP proxies, it's within that context. I'm not going to, just to avoid any kind of duplication, I'm not going to go into that too extensively, but as far as call distribution is concerned and load balancing is concerned, it's all Kamalio based. And then in terms of our breakdown, we're going to just touch on a few applications: voicemail, IVR, call queuing, and call scrubber. Call scrubber, for those of you who don't know, is basically a way of designing a policy server for voice services that allows you to either pass or block specific calls. They're very common for those of you who do call centers already. You know, DNC servers, do not call servers, they apply to that. And so that, of course, is a huge single point of failure for a lot of call centers. And so being important, we're just going to cover it briefly within the application breakdown. So in terms of survivability, the methods we're going to be talking about today, clustering, load balancing, something that a lot of people don't talk about too much, and that's carrier provisioning and carrier policy. A lot of the failures we see within large enterprise telephony projects are due really to carrier error and carrier misprovisioning, where hundreds of thousands of dollars are spent on very well configured SIP servers and ACD servers, but then your upstream carrier policy isn't working or in effect, and so all of a sudden you have a non-working solution when you need it. So I'll just go over some best practices first from our field work and provisioning. The first one being embracing open standards. If you're an Asterisk integrator already, one thing you found is that embracing open standards allows you to do things that other interconnects are unable to deliver, especially at the price. And when I say choose carefully, there are, in my opinion, applicable open standards that should really be pushed, such as SIP, that are very relevant to the rest of the world, and extremely important in terms of carrier interconnect and third-party devices such as session border controllers, media gateways, and things like that. And then there are standards that you could decide to build on, for example, such as EEX, which is a fantastic signaling protocol for Asterisk, but you may run into some issues when you're trying to build a large distributed EEX type of network, and all of a sudden you have to work with other third-party products that are mostly SIP or H.323 based. Always probe and report. We're we found that one of the biggest pitfalls in terms of survivability is that a lot of survivability solutions are built in an A-B model where there's a dichotomy in terms of the way the actual traps for recognition of an outage work in terms of whether something is working or not, right? And so people build routing policies based on whether a route is available or unavailable, right? And that could be like very synonymous to some of the earlier carrier-based IP routing protocols where you could have a route that is 3 or 4 hops away, but at, say for example, 14K, and then you have another route that may be 15 hops away, but at 100 megabits per second, which is clearly the best route, but because you're running a hop-based protocol, such as like RIP version 1, then all of a sudden you're making incorrect routing decisions based on what you're trying to achieve. Well, that also applies very, very much so to enterprise disaster recovery solutions and failover testing. And one thing that we find constantly is that a route may be available, but it may be in terrible shape, right? So how do you make dynamic decisions within your Asterisk and overall telephony projects so that you're actually routing your traffic over optimal routes rather than just routing your traffic over the routes that are immediately available? So that's something that probing really helps us out on, and I'm going to touch on that briefly. The fourth best practice, rather, know your carrier, and I keep on going back to that, especially when I deal with my customers. All carriers are not equal, and understanding how provisioning and carrier equipment are designed and rolled out for every carrier you work with make a big difference, especially on large-scale projects. The type of soft switch you're using, the type of session border controller. Sonus is not the same as Acme. It's not the same as Broadsoft. So getting to know what's actually running under the hood has always made a big difference for us. Outage simulation and DR testing need to become habits. And one of the things that we find is that specifically in the compliance projects we work in, being New York City based, we have a heavy Wall Street financial services pedigree, and so we have to deal with a lot of compliance audits and a lot of disaster recovery testing. And one thing we find out is that disaster recovery plans look fantastic on paper, and they're usually made by people charging hundreds of dollars an hour who are just fantastic at Visio, and sometimes I get Visio envy and I wish I could hire them. But the truth is that unless you make a habit of actually testing your DR plan, and what's more, testing your DR plan by someone who is not familiar with your infrastructure in place, who can just read off of the DR documentation and execute the necessary steps, is really, in my opinion, critical to having a successful disaster recovery plan that is actually executable. Most of the DR plans that we see, survivability plans we see in voice, are actually not executable. There are too many single points of failure, and there are too many options left blank. And in most cases, we see that the people executing the disaster recovery plan are not the people who are familiar with the day-to-day operations of that particular VoIP deployment. So making outage simulation and DR testing a habit, I find extremely important. The next pitfall we see are unreliable database and storage infrastructures. We see this again and again where there are the wrong type of database is deployed, the wrong kind of backend storage is deployed, and when you're talking about Asterisk survivability, one of the key ingredients really is the ability to have distributed databases, especially spread across a wide distance and multiple sites. And the next one I think is incredibly important, especially when you're dealing with a lot of source code. And if you're doing disaster recovery and survivability in Asterisk at the enterprise level, you're going to be writing a lot of source code. and you're going to have to manage a lot of source code. In my opinion, adopting a proper versioning system and linked ticketing system so that those changes are kept track of in a very organized manner, so that as you roll out new versions and upgrades, you're actually able to do so in a smooth fashion is incredibly important. And I'll try to touch briefly on how virtualization helps us with some of those challenges in terms of testing environments. The last few are more related to dimensioning and management, but we find proper SNMP management incredibly important, and that's actually going to be the last detailed section of my presentation. And the last thing, and this also goes back to what we were talking about in terms of the gray areas of a disaster, have to do with actually being able to meet a demand, a spike in demand where you're not necessarily out, but an IVR system that was designed for, say, 500 concurrent ports is now having to deal with 2,500 concurrent calls. You're not necessarily dealing with a disaster or a survivability scenario unless you're improperly dimensioned or you do not have the ability to scale quickly. And I think that's probably the biggest, one of the biggest downfalls we see is the fact that people don't recognize the importance of quick scalability and dimensioning, as they don't recognize it as an actual pitfall in terms of having everything working but not necessarily able to meet demand. And when you're in that scenario, it pretty much is the equivalent of being in an outage. So we're going to talk about call scrubbers real quick. How many people have had to deal with DNC lists and compliance? Okay, all the call center guys. So in our experience, we've had to deal with DNC in terms of Sarbanes-Oxley compliance, where we're dealing with, I don't know how many people saw the movie Boiler Room, right? Where you're dealing with retail investment bankers who are basically cold calling people as telemarketers all day, trying to sell them kinds of crazy stocks. They're bound by Sarbanes-Oxley do not call compliance, and they're going to require blacklisting and whitelisting, so that when people say, please don't call me again, and another eager beaver trader calls them, they do not get the $11,000 per incident FTC fine that the FTC is actually allowed to fine you if you're on a do not call list. The next important market for that is legal/collection. Even if you're actually calling someone legally to collect on a debt, a law firm can have legal grievances filed on them. This happens all the time when people have duplicate names, right? And you're calling somebody where there are, maybe 1,500 Robert Smiths in the book, and there's a naming error, and one poor Robert Smith gets called 15 or 20 times, and those grievances can actually cost law firms a lot of money. Additionally, customer opt-out, of course, is a big important part of any business that's outbound based in terms of contacting customers. And the other one, which is really not necessarily a compliance issue, but can be, has to do with time-based and area code policy scrubbing, right? A lot of sales-based businesses need to quickly be able to detect that a Delaware agent working at home is calling somebody in British Columbia at 8 a.m. Eastern time, which would be whatever 5 a.m. Pacific. So all these things require whitelist, blacklist policy-based servers, which Asterisk makes a fantastic policy-based server for, and we've actually at AstriCon, I think 2008 or 2009, made a whole presentation on just call scrubbing and Asterisk. So to just go over this deployment very quickly, this is your typical medium-sized business that's distributed over a VPLS or MPLS network. I show VLANs 1, 2, and 3. Typically, there are many, many more. But the idea behind this network is that there are multiple sites represented by the VLANs. And now, in many cases, there would be many VLANs per site, but to keep this Visio digestible, I made it shorter. Also, there are some carriers named in this diagram. This is not an endorsement of any carrier in any way. This is just meant to help people just familiarize themselves with the diagram and put it in some kind of context. So in this diagram, we have a PBX cluster and the main customer data center, and then a VPLS network, layer 2, to multiple sites with agents at each site, and then media gateways on site in this particular case. And there's a big single point of failure, right? You have a single call scrubber at the call center, and if that call scrubber goes down, you effectively lose outbound calling for the entire organization. So, excuse me, sorry, it's a little high. So, in this scenario, something we would do would be to create active MySQL cluster with the call scrubber sharing one database. Over time, we got tired of using Navicat, so we actually developed a web-based call scrubber just to not have to enter records manually over an SQL editor. And it's a whitelist, blacklist server. But the idea is that you have the same replicated database across all sites, unified reporting, and now as the site goes live and into production, loss of one call scrub server does not mean any kind of disruption in service, and all media gateways can reroute calls back through an additional site based on congestion. So, like I said, what we saw here are distributed database with active replication, smart redirects, and the ability to route those redirects either through Asterisk or as preferentially via a stateful proxy like Camalio or OpenSIPs for those people who prefer OpenSIPs. Very similar projects. The next application I'm going to discuss briefly is IVR survivability. We have a lot of experience. This is with IVR, large-scale IVR, hundreds or thousands of ports concurrently. And everyone has got a little bit of a different need in terms of their IVR survivability. We've worked with government IVRs. We've worked with wireless carriers for online activations. When you get a new cell phone, you have to call this really annoying IVR that never understands what it is you're trying to dial. I'm sure everyone's had that joyous experience. So I just broke this down in terms of a load-balanced architecture versus an active-passive architecture. So basically, load-balanced meaning that you have multiple server instances behind a load balancer, whereas active-passive, you would have a primary and a secondary never in use unless the active is out of service. Clearly, evidently, the load balance architecture is far more scalable. So this represents an IVR we actually wrote for an online electronics company, a very large one that does all of their order verifications, and FedEx tracking number confirmations. They're a national chain, very, very big company. I'm sure you've all bought stuff from them. Our design approach is to segregate the layers as much as possible. Media gateway-wise, anything above 1,000 ports, we go with something like an audio codes, median, whatever, 2,000, 3,000. And we like to transcode there. And then we send that to load balancer. Typically, Camalio does a very fine job at this level. If you really want to get fancy with a Radware or layer 7 switch, you could do that. But for purposes of Asterisk, IVRs, Camalio, or OpenSIPs, more than suffice. And the idea here is that you have the two proxies in CARP mode. Does anyone know what CARP is? Common Address Redundancy Protocol, basically virtual IP case one fails, the other one takes over. And they load balance those calls forward to Asterisk media servers or IVR servers. The idea here is to spread the load as much as possible so that any loss of one server or multiple groups of servers does not affect the call volume too badly. All those Asterisk IVR servers are running Asterisk real-time. They share backend storage with the SAN usually, or iSCSI, depending on what it is you're doing. We use MySQL typically for these types of projects, depending on the number of records, of course, and Apache for web services, great middleware server. And so in this scenario that you're looking at, calls come in over the media gateways. They get the SIP invite goes to the SIP proxy. Kamalio has a few different really interesting ways of forwarding traffic requests and spreading calls across multiple servers. I'm sure the next talk is going to expand on that, so I'm not going to waste too much time on it. And basically, the Asterisk servers do all of their lookups via AGI script. Most of our AGIs are written in C for speed purposes. And we use Apache quite a bit as a web services middleware server to contact whatever ERP, mainframe, or CRM system the customer has in the back end. Apache does a phenomenal job, and we're able to run all our queries via XML very, very well. So a lot of red squares here. They signify outages. So basically, just to go through this, these outages represent an outage at every layer. And as you can see, you could have, whether you want N+1 redundancy or just active passive redundancy, it's fairly easy to achieve. And in this case, loss of one node at any of these different layers does not disrupt operations in any sort of way. Now, optimally, a lot of people choose to have these segregated by building, by site, with the ever-expanding layer 2 networks that are now available for people to have fiber between sites at really dirt cheap prices. This becomes more and more of a reality for everyone. So now we're basically looking at that same architecture in a purely active-passive scenario where we just have two of each. And as you can see, we have the same survivability. We just don't have the scalability of the load balance deployment like we discussed before. So a lot of customers, especially in the telecom business, are going to require multiple data centers, both for redundancy as well as scalability. And this is one example. This is that cellular service activation project we did, where we actually contracted with a tier 1 carrier and did a mix. Actually, this says voice DS3, but we had a mix of 100 meg SIP circuits and DS3s where calls would come in. They were actually load balanced by the time they came to the media gateways, and then they were once again load balanced internally at each data center to the IVRs, and then those went out as XML queries to the cellular activation server of the carrier. Oops, sorry. So, yeah, sorry about that. Got a little mouse happy. So again, I'm showing here the loss of one site does not affect the overall cluster deployment in any way. Calls continue to flow forward. Typically, in terms of the carrier provisioning, we'll work with a carrier that can detect a no signal and redirect all traffic to the sites that remain alive. And this is one of the reasons why carrier provisioning is really, really important. The next thing I'm going to talk about really quickly, and I know I'm going a bit fast, is survivability at the smaller level. And this maybe actually applies to a lot more people. But we deal with survivability all the time in branch offices and smaller offices where there is one local PBX in a company with a local PBX, or perhaps a branch office with an MPLS backhaul to a PBX somewhere in the main office. So this is an outage scenario, for example, at a small branch office with a gateway. In this case, it's an ADTRAN 9080. So those of you who are in telecom probably have seen more of these than you'd care to know. Right. So this is not an endorsement of ADTRAN. Audio Codes makes something that's very similar. Cisco also has their SRST. It's all pretty much doing the same thing. And what it's doing is essentially routing your SIP traffic. And when the router sees that the SIP traffic is no longer hitting the registrar, it becomes the registrar locally and can redirect calls outbound via POTS line, SIP trunk, local PRI, or send it in stateful fashion to a secondary SIP server or SIP proxy offsite. So what that gives you essentially is the ability to generate your own disaster recovery failover policy at the LAN level, so that if you become disconnected from the main site, that you're able to quickly fail over. The same thing applies to a site with a local PBX, right? In this case, what you do is you segregate your LANs between the PBX and the voice endpoints, so that you're still routing the traffic through your disaster recovery router, usually the loopback interface. And I included Vitality here. Again, not a specific endorsement of Vitality, they're just a recognizable name in the industry as a secondary emergency SIP trunking provider. And what you see in this scenario is the two layers of possible outage covered. If your PRI becomes disabled, then your media gateway can actually fail over instead of the Asterisk server to a secondary SIP trunk. But more importantly, if your PBX actually fails, which is sometimes more likely to happen, your media gateway assumes all voice functions, inbound and outbound traffic continues to flow, and depending on how you configure your proxy, you're able to either redirect those SIP invites to a secondary server you may have on site, or simply work in DR mode until your local technician comes in and replaces the PBX. But all normal inbound and outbound calling functions continue to work despite a total PBX outage. So this is the last point I'm going to go through today, which is quality. Because as I said, what we often find and this applies, I think, a bit more to larger scale deployments where you have dozens or perhaps hundreds of sites, is that not all problems are absolute, right? And this is what happens most of the time to us, especially when dealing with large carriers going through big mergers like Global Crossing and Level 3 and things like that. Things can get messy. And what we find more often than not are not complete outages, but big problems in quality, specifically latency, jitter, and delay, right? I'm sure some of you guys have seen this a lot, where you're not experiencing a total outage, but you've got latency over 300-400 milliseconds, and all this jitter and delay. So your policy to failover, because you're dealing with source policy routes, doesn't kick in, right? You have a few policies in place, and because that SIP target or ICMP probe is still up, your system hasn't failed over. The director of operations is breathing down your neck, saying, how come we spent all this money on a survivable system and we're down and all these things. So what's actually happening is there isn't enough intelligence in terms of actual call routing for the system to determine that despite the fact that things are technically up and your SIP target is technically up, that you're not routing calls optimally due to a major carrier problem. So one thing we really try to instill with all of our customers, if they aren't doing it already, is a very strong culture of probing. Network probes are essential to successful voice over IP deployments, especially when you're going over a few sites over 3 or 4, and when you're doing MPLS or a VPLS, not to mention IPsec, if you're doing something like that, where you need to make sure that every step in the chain of communications at the SIP and RTP level are actually well monitored. And where this becomes really powerful is with an enterprise SNMP monitoring system, right? By the way, what you're looking at now is VQM from Adtran, which is a really useful tool. VQM, yeah. It's built into all their voice products, and you can actually send this out via SNMP to any enterprise monitoring system. This is AppNeta, very similar. They actually install network probes directly on your LAN instead of including it in the appliance, but it's the same kind of idea. And where this becomes powerful is when you have SNMP reporting that can either alert your NOC, VNOC personnel, or actually, make dynamic routing requests either through your stateful SIP proxy or directly to your Asterisk server, depending on how it is that you're routing your calls. But the idea here is that you create mechanisms via these probes to actually optimize routes and change your routing around. Email alerting, I think, being very, very important also. So that's my presentation. I know I went over a lot. Any questions?